So I just want to remind you about the Bernoulli effect, because we were saying that the pressure is higher where there's a low velocity, and as the wind was going across an object, it was speeding up to a higher velocity, causing a low pressure. And I just want to remind you that that is from the Bernoulli effect. So if we looked at a velocity v1, we're going to look at points 1 and points 2 in this shape, and v1 and a1 at point 1, v2 and a2 a smaller cross-sectional area. Remember that Bernoulli effect says that, let's write this down. Bernoulli effect says that the pressure decreases when the velocity increases. Decreasing pressure when increasing velocity. So if P1 and P2, if we compare the two, A2 is greater than A2 is obviously less than A1, V2 is greater than V1, and P2 is less than P1. And that came from when we did our balance of, I think we called it the Bernoulli equation, of course. So it was P1 plus 1/2 rho V1 squared. So the pressure plus the kinetic energy plus the rho GH, which is the potential energy, is equal to the pressure plus the effect of kinetic energy plus the effect of potential energy at the second location. There's no difference in height, so the potential energy term goes away, and we could rearrange this and we could say that P2 minus P1 equals 1/2 rho, which are constants, V1 squared minus V2 squared. And from this equation, if you sit and take some time with it, you can see that these are sort of opposite of one another, that when velocity increases, then pressure decreases. So that's where that comes from, the relationship between pressure and velocity, which is very relevant as you're looking at the conditions around a wind turbine blade.